Remember, anything outside of your parentheses you need to distribute through, and then you need to get x on one side and numbers on the other. If it helps you, draw a line down your equal to sign and move terms accordingly. For number 3, we have to write an equation to solve the problem, and then we have to solve the equation. Brandon has $3 more than Mark, Ashley has $10 less than Mark, and they all have $35 total together. How many dollars does each person have? If you notice, both Brandon and Ashley have a difference from Mark, so I made Mark our variable. We don't know how much he has, but we know Brandon has $3 more than Mark, and we know that Ashley has $10 less than Mark. So those are represented with x plus 3 and x minus 10. Then we know all of them together have $35. So if we add up all three people, Brandon, Mark, and Ashley, set them equal to 35, we get x equals 14. Once you get x equals 14, you can then plug that back into our original equations and say that Brandon has $17, Mark has 14, and Ashley only has 4. Moving on to 4 and 5, solving our inequalities. Again, it's just like solving an equation, except we have an inequality sign and then we have to graph the solution. If it's helpful, again, draw a line down your inequality symbol and solve. Notice how we get a less than or equal to negative 3. So we put our point on negative 3, and it needs to be filled in because it's equal to. And since it's less than and the arrow points to the left and less than equals left, we shade to the left. Again, when you're graphing your solution, remember your solution goes in the middle. You need a number greater than on the right and a number less than on the left. For number 5, we have a compound inequality, so we need to solve each of them separately and graph. Notice how the or means we shade on the outside, or outside, both start with O, and they're both less than or greater than, so we don't fill in the dots that go on our solutions. 4, 6, 7, and 8, we all are dealing with absolute value. Again, looking at 6, you cannot distribute anything inside an absolute value, so you need to get it by itself first. So we divide both sides by 3, and then rewrite our two equations. For number 7, again, you have variables on both sides, so the first one you rewrite without the absolute value. The second one, everything on the right-hand side must be negative. And then make sure you plug them back into your original equation to make sure they both work. That's checking for your extraneous solutions. In this scenario, they do both work. For number 8, again, solving the inequality, absolute value inequality, we have to first add 2, then divide by 3, because we need to get this inequality by itself first. So we get w plus 1 less than 1. And then our second inequality is w plus 1 greater than negative 1. Again, don't forget to switch your sign and make it negative. Once you figure out your two solutions, you must graph. And again, since we started with less than, that means it's an and inequality, a compound inequality. So we can write our variable in the middle, which means we would then shade in the middle of our two solutions. 9 and 10 are very similar. If you look, where we have packages of seeds and they have to vary between 75 and 83. When you add those two up and you find the average of them, we get 79. So the average is always the number that goes with your variable on the inside of the absolute value. And then the difference between the two, so 75 and 79, the difference is 4. 83 and 79, the difference is 4. That is the number that goes on the right-hand side. And you do the same thing for number 10.